You've probably heard of it, right? Schrödinger's cat, the famous paradox of a cat stuck in a box that is somehow both dead and alive at the same time. How is that even possible? Well, today, we're going to pop open that box, metaphorically of course, and get to the bottom of this brilliant and frankly, kind of frustrating story.
So let's just get right to it. Here's the big question. You've got this cat, it's in a sealed box, and there's a device in there with it. If you had to guess right now, is the cat inside dead or is it alive?
And here's where your brain starts to hurt a little. Because according to the strange rules of quantum mechanics, the answer is both. And this isn't just about us not knowing. The theory itself says that until we look, reality hasn't actually made a decision yet. The cat is literally in a smeared-out, fuzzy state of being 100% alive and 100% dead.
But here's the twist, and it's the part almost everyone misses. The person who said this, Erwin Schrödinger, is the guy who came up with the whole cat-in-a-box thing. See, he didn't create this experiment to explain quantum theory. He created it to show everyone how completely absurd he thought it was. He was basically mocking his colleagues.
So yeah, this isn't really just a physics lesson. It's the story of a scientist's incredibly clever, sarcastic argument. He designed this whole thought experiment just to push quantum theory to its breaking point, to show how ridiculous it seemed when you dragged it out of the atomic world and into our everyday reality.
All right, so to really get what Schrödinger was so worked up about, we have to build his little device. So let's take a look inside the box and see exactly how this whole thing is supposed to work. And don't worry, no actual cats were harmed in the making of this thought experiment.
Okay, so here's the setup. It's kind of like a deadly game of mousetrap. First, obviously, you put a cat in a sealed box. Then, you add the most important part, a single tiny radioactive atom. That's our quantum trigger. Next, you put in a Geiger counter, which is just there to listen for that atom to decay. And finally, you hook that counter up to a little hammer, ready to smash a vial of poison. You can see where this is going.
Now here's the key. The whole system, the entire fate of the cat, hangs on one single, totally random quantum event. In any given hour, there's an exact 50-50 chance that this one atom will decay. It's the ultimate coin flip, but, with way, way higher stakes.
And this sets off a perfect chain reaction. If that 50% chance happens and the atom decays, then the Geiger counter detects it and sends a signal. That signal triggers the hammer, which swings down, smashes the flask, and, well, the cat dies. If the atom doesn't decay, nothing happens, and the cat is totally fine, probably just taking a nap.
So we've built the machine, but to understand the paradox, we now have to talk about the truly bizarre rule of quantum physics that controls that one little atom. This is where our common sense just completely goes out the window.
You see, in our world, the normal, classical world, things are simple. The cat is either dead or alive, we just don't know which one yet. It's like if I flip a coin and cover it with my hand. The result is already there, you just can't see it. But in the quantum world, it's different. The atom is literally both decayed and not decayed at the same time. The result hasn't been decided yet.
This mind-bending idea has a name. It's called superposition, and it's a core principle of quantum mechanics. It basically says that until you measure it, a quantum particle exists in all of its possible states at once. It's not one thing or another. It's a wave of all possibilities happening together. And this is Schrödinger's brilliant, sarcastic trap. Because the cat's life is directly tied to that quantum atom, the cat gets dragged into its weirdness. It's forced to inherit the atom's superposition. So, according to the math, the cat itself is no longer just dead or alive. It's in a quantum state of dead cat and alive cat combined.
Okay, that's obviously nuts, right? A cat can't be a weird ghost zombie cat forever. So at what point does reality finally pick a side? This is what's known as the measurement problem, and it's one of the biggest, most intense debates in all of physics.
The whole debate really boils down to this one question. What does it actually mean to observe something? Does it take a conscious human opening the box to make reality choose? Could a camera do it? Or maybe, did the Geiger counter already count as an observer the moment it interacted with the atom?
For almost 100 years, physicists have been fighting over this, and two major ideas have emerged that try to explain when that quantum blurriness snaps into the sharp, single reality that we all know. Okay, so the first and, let's say, the most mainstream answer is called the Copenhagen interpretation. It basically says that observation doesn't need a person. Any interaction with a big, clunky, classical object counts. So the moment the atom could possibly interact with the Geiger counter, poof, the measurement is made. The superposition collapses. The cat was never in a mixed state at all.
It was always either dead or alive, we just didn't know which until we opened the box.
But then there's another answer, a much weirder, much wilder, more science fiction kind of answer. What if the math is trying to tell us something completely literal? What if the universe never actually chooses one outcome?
This is the many worlds interpretation, and it suggests that every time a quantum event like this happens, reality itself splits in two. In one universe, Universe A, the atom didn't decay, and you open the box to find a perfectly healthy, living cat. But at the exact same moment, another universe, Universe B, is created. And in that universe, the atom did decay, and a parallel version of you opens the box to find a dead cat. Both things happen.
So, after all this talk of collapsing realities and parallel universes, what was Schrödinger's actual point? Well, by taking this quantum weirdness and applying it to something as familiar as a cat, he created the perfect metaphor to force us to stare at the real mystery. You see, it was never really about the cat. The cat was just a prop. The real point was to shout from the rooftops this huge, unanswered question. Why does the tiny world of atoms follow these insane rules of superposition, while our big, everyday world of cats and boxes and people is so solid, so definite?
So, in the end, Schrödinger's cat isn't really a paradox to be solved. It's a question that forces us to confront the biggest mystery of all. We still don't know how the fuzzy, probabilistic, anything-can-happen quantum world builds the solid, predictable reality we live in every single day. And that is the real puzzle inside the box.